we will discuss about shear force and bending moment part 2. Okay, what is shear force? Shear force is suppose there is a beam like this, simply supported beam, and there are loads like this. This is a point load P acting, and this is a uniformly distributed load acting per meter run. So here, if suppose we consider a section XX, and the total forces, the sum of forces acting in this particular section XS, either if we consider from the left side or from the right side. Anything is fine. We can calculate from the right side or left side. So the total sum of forces acting on this, or the algebraic sum of forces acting in this particular section XS, is the shear force in this particular section. So shear forces are regarding the vertical forces, the transverse forces acting on this section. And bending moment. Bending was in similar manner in this section axis, the net moment acting in this particular section axis. Either we can calculate from the left or right of the section. That is called bending moment. The net sum of moment in this particular section x6 while calculating it either from the left or from the right. That is the bending moment of that section. So while studying this shear force and bending moment, if you want to draw this, we have to know very few simple things. So let us discuss what these are. See, first of loading. Loading we represent as W per meter run, and we'll have so W load per meter run means kilonewton per meter will be its unit, and we will have shear force of unit kilonewton, that is the total sum of forces, so that will be of unit kilonewton. And we have bending moment. See, bending moment is of unit kilonewton meter, that is force per unit, sorry, force into perpendicular distance, so that is kilonewton meter. So see, from this we can simply just write like this. See here, kilonewton meter, this by meter will give you shear force, and shear force unit is kilonewton. See, kilonewton by meter will give you loading. So what is there? See, shear force is differential of bending moment by dx. Dx is the distance. Okay, so that is shear force, and we will have loading. Loading W is equal to d of shear force by dx. See, in checking these units, we can just simply see kilonewton meter by meter and kilonewton by meter. So in that manner, we can just learn this. Okay. So that is it. See, so what will happen? Bending moment will be like integral of shear force into dx, and from this you will have shear force is equal to integral of loading into dx. The area under the loading curve will give you shear force, and area under the shear force will give you bending moment. It just means that starting from loading, if loading is of x raised to 0 degree, then you will have shear force of x raised to 0 into dx means x degree, x raised to 1 degree. And if you have shear force of x raised to 1 degree, it means that x raised to 1 into dx. That means you will have bending moment of x square degree. So it will be loading 0 degree, then shear force 1 degree, and bending moment will be 2 degree. So this will be our pattern. So let us check various cases. W, then shear force, then bending moment. See, if the loading is like this, there is no variation. See, if P is acting like this, equal and opposite force. There is no variation in the load. Then what will happen? The shear force will be of 0 degree. Then bending moment will be of x raised to 1 degree. 0 degree, x raised to 0 degree means that it will be parallel to the axis. It will be horizontal. Okay, then it will be like a horizontal line. X raised to 1 degree means what? It will be like uniformly varying, like from x is varying. X is equal to 0, it will be 0. X is equal to 1, it will be 1, like that. it will be like a straight line. Bending moment is varying with x raised to 1. So x is 0, 0, then x is 1, 1, like that it is varying. So the distribution will be like a inclined straight line. Then we will have the second condition as uniformly distributed load. In uniformly distributed load, you will have variation, constant variation, that is x raised to 0 variation. Then you will have shear force as x raised to 1, that is like this straight line, inclined straight line, and bending moment of x square, that is square parabola. It will be like this. And the next one is uniformly varying load. Uniformly varying load means that is x raised to 1 variation, and you will have shear force of x raised to 2 variation, that is a square parabola, and you will have bending moment of cubic parabola, that is x cube variation, cubic parabola. And if there is a moment as loading, then shear force don't have any effect, nil effect will be there on shear force. And in bending moment diagram, there will be a sudden jump, like suppose in this position, at this point you have a moment, means at C point you have a moment, there will be a sudden jump in the jump or fall in the shear force, sudden change in the jump or fall in the bending moment diagram. So these are regarding this. So this is very simple, right? From that kilonewton per meter, a kilonewton meter, we have found out the relation between loading, shear force, and bending moment. And from that we have understood 0 1 2 3 0 1 2 variation it is having. So if there is like constant, there is no variation, then it will be x raised to 0 and x raised to 1 variation. If it is x raised to 0 variation, that is, it is like a constant value, then you will have x raised to 1 variation and x square variation. And square means it is a square parabola, and if it's like x raised to 1, it is uniformly varying, then you will have a square parabola as shear force diagram and cubic parabola as bending moment diagram. If there is a moment, there is no change in any value in the shear force diagram, but you will have a sudden jump in the bending moment diagram. So these are the cases. Then one more thing, you know that dm by dx is equal to shear force. So if m is maximum when shear force is equal to 0. This you already might have studied in maths. So same thing is happening here. And we will now discuss about one thing, that is point of contraflexure. See, you will have a simply supported beam. This is a simple example of that. Okay, here a moment is acting at this point. So because of this moment, see, there is something called an elastic curve. Okay, elastic curve. See, elastic curve. Elastic curve means the way in which the axis of the member bend. That is what it means by an elastic curve. See this, because of this moment, see the arrow of this, see it is putting like this on this member. So what will happen? The member bend like this, and see on this member how it act like this member. So it will be like this. See the curve. This is the elastic curve. This is the elastic curve. So here see, at this point see, the particle, the body, the beam is like having a change in the curve. So the beam's tension side in this portion is here upward, and then the remaining portion is downward. So that it is totally changing its direction here at C point. So C point is called a point of contraflexure. Point of contraflexure. Contraflexure. Bending moment changes its direction from positive to negative or negative to positive at this point. Okay, so that is it regarding all this. These are the things we have to primarily understand about bending moment and shear force diagram. Then we can study bending moment and shear force diagram very easily. And sign convention is there. If you first move this part, if there is a part like this, here the first section move up and here it moves down. This sign is taken as positive in shear force diagram. You will understand this while we do problems. Okay, and the next one is bending moment. If it is like beam member is bending like this, see, this is sagging case. See, for a beam cantilever, simply supported beam, there is a load W acting. See, actually, we will this bending moment diagram is very important for interviews, for all competitive exams. This bending moment diagram is always asked. Shear force diagram also. But see, this bending moment diagram, there is a very simple method. Most of you might not be knowing about that. Bending moment diagram can be easily understood in a way. See, the way in which the elastic curve was deforming. Okay, that is very important. See, because of this load W, this is a point load. See, the member will behave like this, now elastic curve will be somewhat like this. So this itself will give the how the bending moment diagram will be, how will be the BMD, that will be exactly given by the elastic curve. Okay, so this most of the time people don't understand about this concept. The elastic curve is an indication of bending moment diagram. We will discuss about in our other two lectures. Okay, so this is the case. So see here, because of this load, the member is sagging. This is a sagging curve formed. So because of this sagging, see see, this is a man. Okay, this man is smiling. So this sagging is taken as positive, and hogging the man is sad. So that is taken as negative. See, the man is sad. This is a case when man is sad. See, there is a moment acting on this, and this moment, what will this moment do on this member? See, the moment is doing like this. The member is going like this. See, the elastic curve will be like this. Here it is fixed, so there is no any change in the orientation. See, after that, the member will orient like this. So the member is very sad. So that is hogging. This is a case hogging, and this is sagging. So like this, it is the convention is taken, and the bending moment, it is always drawn on the tension side. See, because on the where the member is bending, there will be a tension on that side. See, here there will be a tension on this side on the top, and here there will be a tension on the bottom side. So we always draw bending moment diagram on the tension side, so that by checking the bending moment diagram, we know where we have to put the steel. Steel is always put on the tension side in RCC structures. So that is the concept with the bending moment diagram. We will discuss about the various problems, various simple problems and various complex problems in the next two lectures. So do follow these lecture properly. Do subscribe and press the bell notifications if you haven't already done. Thank you.